Hello again, calculus. So at this point, we're going to go over a couple more examples. We are on page 53 of your packet. We're going to go through 6, 7, 8, and 9 together here. This is a combination of using our two rules. I'm going to write them up at the top. The limit of sine x over x if x is approaching 0. And our newest one that you guys discovered just a few moments ago, the limit of this other function, 1 minus cosine x over x, as x is approaching 0. Both of these functions have holes at x equaling 0, so we can't plug it in. But we know that this guy equals 1, and this guy equals 0. We can use them as needed in our analysis here. So let's go for number 6. Number 6, I see that through direct substitution, I would have division by 0. No good. So I'm going to see what can I do with this. Well, I see this cosine over theta here, and we need a 1 minus involved. And there is a minus here, so maybe I can do something with that. Here's what I'm going to do. I'm going to factor out that 2. And I'm just going to ignore the limit for now. I'm just going to rewrite with the function. So if I factor out a 2, I'd be left with 1 minus cosine squared theta all over theta. And hopefully this you recognize from our Pythagorean identities is the difference of squares. So I'm going to factor that. So I have 2 times 1 plus cosine times 1 minus cosine over theta. There we go. Now, why that is helpful to me, I see my 1 minus cosine theta over theta, meaning this whole shebang is just 0. Now, let's make sure that all of this stuff was workable before. What I mean by that is if this stuff is undefined, it doesn't matter that this whole thing equals 0. But if it is defined, then multiplying by 0 tells us our answer. So let's just try real quick. If we plugged in 0, cosine of 0 is 1. So all of this is doable right here. All of this is defined. Meaning, if it is defined, if we were trying to find the limit as theta is approaching 0 of 2 times 1 plus cosine theta times 0, which is all this stuff, the whole thing, we know multiplying by 0 just gives us 0 as our final answer. So that's that. Hooray. There's another way you could have done that by, again, using the difference of, not the difference of squares, the Pythagorean identity right there, substituting in sine squared instead, and then using the sine identity instead of the cosine. But notice it gives us a good answer this way too. So if you want to experiment with that and using the sine identity that we talked about already, you can do that. Let's take a look at number 7. Oh, and feel free to pause and rewatch this video as you need to, and ask questions of each other as you need to make sure you understand this example. Let's go to number 7 next. Number 7. I see sines and cosines, so I'm like, whoa, there's a lot of stuff going on here. But one thing I have in common with my two identities here, they both have good old one single variable in the denominator, which is what I have here. Remember, whenever I see that and a function on top with addition and subtraction, I am allowed to separate it and divide out any way that's helpful. In fact, there is a very helpful way for me to work with this one. So I see both of my identities in this. So here we go. I have the limit as theta is approaching 0 of this first guy here. We have 1 minus cosine theta over theta. Beautiful, just as I wanted. And the other guy, the limit as theta is approaching 0 of sine of 2 theta over theta. And we know how to handle that to fix it. I need a 2 in the denominator, but I can't just put a random 2. I need to multiply by 1 to make it work for me. So then this whole guy I know goes to 1. This whole guy, this whole guy goes to 0. And it's this whole guy that goes to 1. Therefore, the only thing I'm left with, over here, I have the limit at 0, which I know the final answer is just 0 for that, plus the limit of 2, which I know is just 2, so my final answer is 2. And that's that on that one. And let's go for the last two. Number 8. This one's interesting. I see cosecant involved, not sine or cosine. So what I'm going to do is try to rewrite this with sine, because I know that 1 over cosecant or 1 over sine, they go for cosecant and sine interchangeably. So let's try this. I'm just going to rewrite each of these cosecants as 1 over sine, and maybe something helpful will happen. So here we go. And again, I'm just going to kind of draw that limit down. Like it's there the whole time, I promise. So here we go. We have theta out front stays times 1 over sine theta plus 1 all over theta times 1 over sine theta. There we go. Now, up here, I'm going to bring these guys together, so it's one fraction, and I'm going to try to add the 1 to it. Now, I'm not just going to be able to randomly add the 1. I'm going to need to get a common denominator so I can add these two things, these two fractions together. Completely ignoring the denominator for now. That will be there in a little bit. So here we go. Next step. This guy becomes theta over sine theta plus my 1 that I'm adding. I'm going to make it sine theta over sine theta, because now I have a common denominator there. So that's just the 1. And in my real overall denominator, I'm going to make this a single fraction. So I just have theta over sine theta. Now, I don't necessarily expect you guys to have known to do that, and that's why I'm showing you this. This is a tactic you can use in the future. So, getting cosecant into sines, making this one fraction. The next couple steps, our goal is just to make one nice fraction, not double fractions within fractions craziness. So when I add these together, I'm going to get one fraction, but then I also have this guy in the denominator. So let's first add on top. So I have theta plus sine theta over sine theta divided by, I'm going to make it a little bit bigger there, theta over sine theta. Again, I have double fraction within a fraction. So I'm going to simply multiply by the denominator, reciprocal instead, to try to make this one nice fraction finally. Again, all these steps are just making one nice fraction right now. So I have theta plus sine theta over sine theta multiplied by the reciprocal here. I'm going to have sine theta over theta. And again, that's because we don't like dividing with a fraction. We multiply by the reciprocal instead. There we go. So I see that this sign and that sign cancel each other away. I am left with theta plus sine theta over theta. Just like in number 7, I'm going to split this and divide 2 ways because I see that identity that I'm looking for there. So that all comes down to theta over theta plus sine theta over theta. And now I am going to go back into nice limit writing here. We know this guy is 1. Like this whole is just 1. So I really have from here the limit of 1 as theta is approaching 0. It doesn't matter that it's approaching 0. We know the limit is just 1 plus the limit as theta is approaching 0 of sine theta over theta. And that whole shebang we recognize. We say it's just 1. So I have 1 plus 1. My final limit is 2. There we go. Alrighty, last one. I know this is a longer video, but I want to get all 4 in here. Number 9. we have a lot of stuff going on. It seems to be a lot of stuff going on. I see my sine in the numerator, my cosine in the numerator, and the x in the denominator, but it's x squared, and like there's sine and cosine being multiplied together. What's going on with that? So here is a tactic for us for this one. I am going to factor out the sine. By doing that, notice what's left over. If I divide sine x by sine, I'm left with 1 minus sine cos divided by sine is just the cos. This is looking quite familiar, which is nice. And we know that x squared is just x times x. What I'm going to do is break this apart with multiplication. So we've broken apart a fraction with addition several times. Let me scroll back up to some of those. Right here, we had addition and subtraction, so we broke it down. They each got theta in the denominator because it was the common denominator. Same down here. They both were divided by theta because it was our common denominator. What we need to do with this guy, though, since we're only multiplying, we have this sine x, then we have this factor 1 minus cosine. I'm just going to break this apart. Here's how. I'm going to have the limit as x is approaching 0 of sine x over x times 1 minus cosine x over x. So that whole shebang. And notice again, we can check to make sure it came to this if we were going backwards. Sine x times 1 minus cosine x. In the denominator, x times x does give me x squared. So now this guy, we have all sorts of great things happening. I know the limit of the sine bit, and I know the limit of the cosine bit. And remember, I can just break this limit down into two separate limits that are being multiplied. We learned that rule a couple weeks ago. So if this whole guy equals 1, and this whole guy equals 0, 1 times 0, my final answer is 0. There we go. Alrighty. So again, pause as you need to in this video. Ask each other questions. Talk to each other about these if you have any questions here. For homework for the rest of class and for this evening, in this packet, I would like you to try last page of the packet, 9, 10, 11, and 12. It's the top 4 boxes there. It is a mixed review of the sine x over x limit and the 1 minus cosine over x limit as well. There we go. And again, you may talk to each other, ask each other questions. We will check this together on Thursday.